This is Algebra 2 with Trig, working on Unit 9. This is the 9.5, 9.6b review. It took 41 minutes to do this mean, median, and mode. Crazy group of questions. But now we're moving on to the good stuff. Talk about normal distribution. So we have a normal distribution of X bar that goes there in the middle. We want to know the probability that a number is greater than the median plus one standard deviation. Okay, so that goes on forever in that direction. So this would be 13.5 and 2.35 and 0.15, so that's going to be a total of 16, which is 0.16 as an answer. Okay, probability has to be a number between 0 and 1. We want it to be larger than 3 standard deviations below the mean. Well, the mean's in the middle. That's 1 standard deviation, 2 standard deviations, 3 standard deviations. We want it to be greater than that. That's all of this. Okay, so that's everything but 0.15. So if we look at 1 minus 0.15, because we're going to take everything minus the little bit we're not using. So this is 0.9985. Okay, give the percent of the data underneath the curve in the shaded region. So it looks like this is 0.15, this is 0.15, so that's a total of 0.3. The percent, alright, this is 0.3 percent, because this is 34%, 13.5%, 2.35%, 0.15%. So it would be 0.3%. Here, drawing some pictures can be handy. We have a normal distribution of mean of 27 with a standard deviation of 12. So that'd be 39, 51, 15, 3. Okay, we want to see about going from 12 up to 27. Oh, where did I mess that up? Oh, my bad. I messed that up. The standard deviation is 5. I got 12 from this. Standard deviation is 5. So up by 5 would give you a 32, and up by 5 would give you a 37. Down by 5. This isn't possible. I'll explain why here in a second. Oh, my bad, there's our 12. Okay, so this is 34% of the data, 13.5% of the data, 2.35% of the data. So we are all in between there. So we have 30, 40, 47.5, 49.85. That would be a percent. We want to know the probability. So probability is going to be a decimal between 0 and 1. At least 22. Well, the average is right there. Then we have 22. So at least means that or bigger. So we have 50% plus our 34. That gives us 84. And in terms of a probability, that's our 0.84. At most 32. So we have 27, 32. Now at most, that means we're going this way. Again, it's going to be the 50%, and it's going to be the 34. So the 50 and the 34 is 84, so that's 0.84. A normal distribution has a median of 75, standard deviation of 10. Alright, let's take a look at what this all means. So if we have 75, and here we go up to 85 and 95 and 105, this would be 65, this would be 55, this would be 50. Well, we want to know the probability of 52 or smaller. Okay, but 52, that's not landing right on a standard deviation. So we have to find a z-score first. So 52 minus our 75 over our standard deviation of 10. So that gives us negative 2.3. Alright, so if we want to know the probability that x is less than 52, which is the same thing as the probability that z is less than negative 2.3, that's what 52 is. It's the number of standard deviations below the mean, so that's 2.3 standard deviations. So what we're going to do, we're going to look on our table at negative 2.3. Negative 2.3. You can read that or not. We got 0.0107. .0107. Alright, this would actually be 45 here, not 50. Not that it changed a thing. Not that it changed a thing, but you may have noticed that when I did my little numbers, that should, going down by tens, that should have been 45. Alright, so 93. 93 is not falling in our group, so we're going to do a z-score of 93 minus our average over the amount that we're changing. So 93 minus average divided by 10, which is 1.8. So the probability that x is less than or equal to 93, which you could also call it the probability that z is less than or equal to 1.8, this first table are the negatives, the second table is the positives. We're looking for 1.8 right there at 0.9641. 0.9641. Okay, last one. We have a z-score of 105 minus 75. That's a distance of 30. So what's the probability that our z-score is less than or equal to 3? We have our negatives. We have our positives. We're looking at 3, so that's 99.87. The annual per person consumption of apples. 16 pounds is average with a standard deviation of 4. They're telling us to find the z-score, and we want to find the consumption of 22. What percentage of the people? No, they just right now they just want us to do the z-score, so that's easy enough. So our number is 22 minus the average over the standard deviation. So that's 6 over 4. Looks like 1.5. Now what's the probability that a person in the United States consumes less than 22 pounds? So the probability that our x is going to be less than 22 pounds will be the same thing as a probability that z is less than 1.5. We've got our negatives. Got to go to the positives to 1.5, and that's 93.32. 93% of the population eats less than 22 pounds. And that is it. What I see that we didn't cover here in this review, we didn't cover greater than. So if we wanted to know greater than 105, don't forget we'd do 1 minus 0.9987. We'd have to do those calculations, and that would be your probability. If you wanted to know greater than 93, you'd have to do 1 minus 0.9641. Alright, very well.